So yesterday we have listed 7 indeterminate forms which are listed again here. 0 raised to plus infinity and 0 raised to minus infinity, they are not indeterminate. 0 raised to plus infinity will go to 0 and 0 raised to minus infinity will go to plus infinity. The explanation for the first one, 0 raised to plus infinity is equal to 0, is over here. Taking logarithm of both sides, etc., you end up getting 0. Okay, now examples of these types one by one and try to solve it. Okay, now what is Lopital rule? I mean, if we wish to solve indeterminate form, we can always use this rule. It is very convenient, and maybe some of the problems you can solve using first principle also, but this is very handy trick. So L'Hopital is basically like this. If you want to find out limit x tends to c f of x upon g of x, and if f of x tends to 0 and g of x tends to 0, if x tends to c, then of course I am writing it in short. What is L'Hopital? We will, when we prove the L'Hopital theorem, we will write complete correct statement of L'Hopital rule. But if you want to find out limit of this where it is in the indeterminate form, the moment you substitute x is equal to c, it goes in 0 upon 0 or any one of these indeterminate forms, but essentially this, then limit, let us call this, suppose this limit exists and is equal to L. How do I write this? Maybe not. Then limit x tends to c f dash of x upon g dash of x is also equal to limit x tends to c f of x upon g of x. Okay, so if you really want to find out this limit, maybe you differentiate numerator, differentiate denominator, and you get out of indeterminate form. And if you happen to get out of indeterminate form after differentiating numerator and denominator, then evaluate this limit, and suppose this limit exists and its value is equal to L, then L'Hopital rule says the value of this limit after differentiating numerator and denominator, whatever you get, is going to be value of the limit of the original problem, that is f of x upon g of x. So this is very, I mean, path breaking trick of evaluating limits. Somebody who have found it out for the first time, because it, I mean, so many complicated functions, composition of the functions, every time it might not be possible to evaluate using first principle. Algebraic complications become so high that you won't end up finding out the limit. This makes the life easy. This is very useful trick and extensively used. Okay, L'Hopital. Of course, there are different versions. I have written here for 0 upon 0 form. We will have to have it for infinity upon infinity form. Whether it is true or false, we don't know. We will figure out. I mean, there are more than one theorems under this, which eventually we will see and write the proofs of them. However, let us learn to evaluate limits using L'Hopital. First problem. Limit x tends to 0 e raised to x minus e raised to minus x minus 2 log 1 plus x divided by x sine x. Now see, in this particular problem, you have exponential function, you have logarithmic function, you have algebraic function, you have trigonometric function, and limit is supposed to be established. So using first principle, this is going to be long. I'm not saying that it is not possible, it will be long. So using Lopital, it will be very, very quick. So find out limit of this and show it to me. Form. This is 0 upon 0 form. So apply a L'Hopital. So that means this should be equal to limit x tends to 0 derivative. E raised to x, derivative of e raised to x is e raised to x. Derivative of minus e raised to minus x is plus e raised to minus x. Derivative of 2 log 1 plus x is minus 2 upon 1 plus x. Now derivative of numerator upon derivative of denominator. X cos x plus sin x. Now if you substitute again 1 plus 1, that is equal to 2, and then if you put 0, 2 minus 2 again 0, then 0, that makes this 0 and this is 0, therefore again 0 upon 0 form. So that should be equal to limit, differentiate again, e raised to x minus e raised to minus x. What is derivative of this? Minus 1 plus x into 0 minus 2 into 1 upon 1 plus x bracket square. That is the derivative of this term, denominator. What is derivative of denominator? Minus x sin x plus cos x plus cos x. Is that right? Now if you substitute x is equal to 0, you end up getting this 1 minus 1 and this is plus 2, 0. If you substitute x is equal to 0, this is plus 1, which is 2 upon 2, which is equal to 1. That is why limit of this is equal to 1. Okay? अरे समझ लेगा? Question number 2. Now this is infinity upon infinity, same way you have to go about it. Limit x tends to pi by 2 tan 3x upon tan x. Write the answer. How do you go about it? Let me quickly write it. Limit, this is equal to limit x tends to pi by 2, 3 sec square 3x upon sec square x, which is equal to limit x tends to pi by 2, 3 cos square x upon cos square 3x. बराबर है. This will be equal to x tends to pi by 2 minus 6 cos x sin x upon minus 6 cos 3x sin 3x equal to limit x tends to pi by 2 sin 2x upon sin 6x, which will be equal to limit x tends to pi by 2 cos 2x upon 6 cos, it is 6 by 6 cos 6x. Now you are out of indeterminate form. and therefore answer is 1 by. Next problem. Question number 3. Limit x tends to 0, x log x, and x tends to 0. So this is 0 into minus infinity form. See how you deal with it now. It is 0 into minus infinity type. So you have to first convert it into 0 upon 0 form, because you cannot differentiate this directly. So you convert it into 0 upon 0 form. There are two ways of doing it. You either convert it into 0 upon 0 form or infinity upon infinity form. And you may not get answer in one case. You may get answer in the other case. So suppose by mistake if you convert it into 0 upon 0 form, which is limit x tends to 0, x upon 1 upon log x. Now this is 0, this is minus infinity, therefore this is becoming 0. So 0 upon 0, you will get the answer. Because why will you not get the answer? You will grow this, and every time you will keep getting indeterminate form. So this will not lead to answer. Derivative of x is 1, but derivative of 1 upon log x is going to be miserable, and it will increase, it will grow, the function will grow. We don't want that to happen. Therefore, we will consider limit x tends to 0 log x upon 1 upon x. Okay, this is actually infinity upon infinity time. But then right now it is infinity upon infinity, so we differentiate 1 upon x upon what is the derivative of 1 upon x, which is minus 1 upon x square, which is 0, minus x, correct? Okay. Question 4. Any doubt? No. Good. Limit x tends to 2, 1 upon x minus 2 minus 1 upon log x minus 1. सांगा उत्तर द्या. Okay, this is equal to limit x tends to 2, cross multiply log x minus 1 minus x minus 2 upon x minus 2 log x minus 1. Now if you substitute 2 here, then this is log 1, which is 0, 0 minus 0 is 0, upon this is 2, 0 into 0, so 0. Okay, now it is, earlier it was infinity minus infinity form. Now using algebra we converted it into 0 upon 0 form. Now Lopital, limit x tends to 2, 1 upon x minus 1 minus derivative of x minus 2 is 1, divided by x minus 2 into 1 upon x minus 1 plus log x minus 1. This is after differentiating, correct? So what do you get out of this? If you substitute 2, this is 1 minus 1, again 0. So let us simplify a bit. 1 minus x plus 1, correct? Therefore, this is divided by x minus 1. This is 2 upon x minus 1. So x minus 2 plus x minus 1 log x minus 1. Right? So if you again put x is equal to 2, you will end up getting 0.0. Differentiate. Derivative of numerator minus 1 divided by, now derivative of denominator 1 plus x minus 1 upon x minus 1, that is first part, plus log x minus 1. बरोबर है? Yes. Now if you substitute x is equal to 2, you get minus 1 upon 1 plus 1 plus 0 is equal to 1 upon 2 with negative sign. Question number 5. Any doubt, difficulty, you can ask him. Limit x tends to a, x minus a raised to x minus a. Kada. So answer for question 5 is 1, and the procedure is same. This is something similar to question number 3. Limit x minus a log x minus a as x tends to a, which is 0. So log of limit x tends to a y is equal to 0. Therefore, e raised to 0 is equal to limit y, which is equal to 1. Next problem is limit x tends to 0 cos x raised to cot x. Limit log y is equal to limit x tends to 0 log cos x upon tan x, which if we differentiate, we get limit x tends to 0 1 upon cos x, derivative of cos x minus sin x whole divided by derivative of tan x sec square x. If you simplify, you get limit x tends to 0 minus sin x cos x. Is that right? If you substitute, you get equal to 0. Therefore, log of limit x tends to 0 y is equal to 0. Therefore, limit x tends to 0 is equal to e raised to 0 is equal to 1. Question number 7. Limit x tends to 0 tan x upon x raised to 1 over x. Limit log y as x tends to 0 is equal to limit x tends to 0 log, no, sorry. मी जुन्या प्रॉब्लेमचं सोल्युशन लिहितो. लिमिट लॉग y इज इक्वल टू लिमिट x टेंड्स टू 0 1 upon x log tan x upon x, which is tan, so again subtraction. So limit x tends to 0 1 upon x times log tan x minus log x, which is equal to limit Now what do we do? What is this form? This is upon x. As x tends to 0, tan x becomes 0. So this is minus infinity, minus, minus infinity. Correct, na? So can we apply L'Hopital here? Minus infinity, minus, minus infinity. That is
Sir,
yes.
if we do log of tan x upon x, we know that tan x upon x will tend to 1. So the log will tend to 0. So we get 0.0.
Log of 1. Oh, okay. So you mean to say we write it here, this divided by x, and the limit of this is 0 and limit of this is 0, therefore we can apply L'Hopital. But while applying L'Hopital, we can use this property of logarithm, and therefore we will get limit x tends to 0 sec square x upon minus 1 upon x. Okay, again this is infinity minus infinity form, so you simplify, you get limit x tends to 0 1 upon cos square x into cos x upon sin x minus 1 upon x, simplify, which makes it limit x tends to 0 x minus sin x cos x upon x sin x cos x.
सर अपॉन एक्स घ्यायचा राहिला
0.0 फॉर्म काय?
सर अपॉन एक्स घ्यायचा राहिला सर आपला
आपण काय त्याचं डिफरन्शिएट केलं ना, दिस इज आफ्टर डिफरन्शिएशन. अपॉन एक्सचा डेरिव्हेटिव्ह 1 झाला, कळलं का?
हो सर
लिमिट x tends to 0 2x minus sin 2x upon x sin 2x, which is equal to limit x tends to 0 2 minus 2 cos 2x upon sin 2x plus 2x cos 2x, which is equal to 4 sin 2x upon 4 cos 2x minus 4x sin 2x. I am applying L'Hopital and L'Hopital and L'Hopital. Okay, and I have reached this stage where I got it 0. Therefore, limit y x tends to 0 is equal to 0. Hence, y right? Limit log y, log of this is equal to 0. Therefore, limit y x tends to 0 is equal to e raised to 0 is equal to 1. Bola, any doubt in this solution? कोणती स्टेप? पहिली ही 1 upon x इथे लॉगॅरिथम घेतला ना दोन्हीचा.
हो सर, म्हणजे अपॉन एक्स तो आत कसा गेला लॉगच्या?
लॉगच्या आत नाही गेलेला, तो बाहेरच आहे. लॉगच्या आत कुठे गेलाय? फक्त तो 1 upon x लिहायच्या ऐवजी मी त्याला इंडिटर्मिनंट फॉर्म दिसायला पाहिजे म्हणून 0 upon 0 लिहितोय. दिस इज 0, दिस इज 0. चालणार आहे का? बघा चेक करा सगळ्या स्टेप्स. आय थिंक ऑल ऑफ देम आर करेक्ट. क्वेश्चन नंबर 8. Limit x tends to infinity, e raised to x plus x raised to 1 upon x. This implies limit x tends to infinity log y is equal to limit x tends to infinity 1 upon x log e raised to x plus x. Right? This is infinity upon infinity form. So differentiate. So 1 upon e raised to x plus x, that is what is derivative of log x, into derivative of log x into inside e raised to x plus 1 upon derivative of x is 1. Correct? Which makes it limit x tends to infinity. So limit x tends to infinity e raised to x plus 1 upon e raised to x plus x. Again infinity upon infinity, so differentiate limit x tends to plus infinity e raised to x upon e raised to x plus 1. Correct, no? Again infinity upon infinity, differentiate limit x tends to infinity e raised to x upon e raised to x, which is equal to limit x tends to infinity 1. Correct? So limit log of limit y, limit x tends to infinity is equal to 1. Therefore, limit y x tends to infinity is equal to e raised to 1 equal to e. Question number 9. Limit y tends to 0 plus cos 2y raised to 1 upon y square. Solve. Okay, the answer for question number 9 is e raised to minus 2. Okay. Okay, I have a bunch of more questions like this, but I would like to give you something different now. May not be Lopital, but little different. Question 9 झाला ना? Okay. Question 9. Question 10. Limit x tends to 0, greatest integer sin mod x upon x. This is greatest integer function. Therefore, you have to consider two limits. Limit x tends to 0 plus. That means you are approaching 0 from right hand side. And limit x tends to 0 minus. That means you are going from left hand side. Okay. Now we have proved earlier that sin theta is less than theta. Correct, na? as theta tends to 0. Sin theta is always less than theta, not necessarily as this. Okay. So if you are approaching towards 0 from positive side, this absolute value does not make any sense. It is sin x upon x, and numerator is going to be smaller than denominator, and therefore this fraction is going to be less than 1. Therefore greatest integer of that is going to be 0. When you approach from left hand side, this is going to be important. So it is minus of sin x upon x, and again numerator is going to be smaller than denominator. The fraction is going to be less than 0, but with negative sign, whose greatest integer is going to go and land at minus. So the right hand limit is 0. Left hand limit is minus 1, therefore answer does not exist. Question number 11. Doubt असेल तर विचारा. I can explain it again. Limit x tends to 0, greatest integer function, leave sin mod x upon mod x is how much? Okay, this is easy because you get rid of that minus sign because of this x now. The minus sign you get rid of, and therefore you get both the limits 0, and therefore answer becomes 0. Question number 12. Limit x tends to 0, greatest integer function sin signum of x divided by signum of x, greatest integer complete, is equal. So what is the explanation? What is the answer? Explanation is signum function is, काय असतं सिग्नमची डेफिनेशन काय?
One if x greater than 0, minus 1 if x less than 0, and 0 if x equal to 0.
Okay, so if limit x tends to 0 plus, so this is sine of going to be, it is going to be equal to 1, sine of 1 divided by 1, correct? Sine of 1 is going to be less than 0, therefore greatest integer of positive quantity less than 1 is going to be equal to 0. Limit x tends to 0 minus, answer sine of opposite of 1 upon opposite of 1, correct? Which is minus sign gets cancelled, fraction remains same, greatest integer of that fraction which is less than 1 but positive is again going to be equal. Therefore answer for this is C. Very good. Question number 30.
Sir,
Hmm.
sir, पण at x equal to 0, limit does not exist असणार ना?
At x is equal to 0 म्हणजे काय? प्रश्नाचा अर्थ काय? प्रश्नाचा अर्थ काय?
काही नाही सर.
काही नाही ना? Good. Limit x tends to 0, sin greatest integer x upon greatest integer x is equal to. करा विचार. Okay, answer for this is sin 1. If you are walking on real number line and you are tending to 0. So you can consider limit as x tends to 0 plus and limit x tends to 0 minus. These are the two limits that you have to consider. Now, if you consider this limit, then it is easy, because if you go near 0 from negative side, your x is approaching 0, say 0.1 of minus 0.1 or minus 0.009 or something like that. You can always assume these numerical values. And if you put it inside the greatest integer sign, it will throw you to minus 1. So practically what you are finding out, as you tend to 0 from negative side, your actually function is sine of minus 1 upon minus 1. This is the function that you are dealing with when you are approaching 0 from this side, right? And if this is your function, then it is independent of x, therefore value of this function is sine 1, correct? But at the same time, if you are going to 0 from plus side, then it is going to be sine 0 upon 0. And this is a bad function. I mean, this is a bad function. That means this is not defined. So you cannot actually put the values. You cannot go to 0 from right hand side. It is out of the domain of the function. It is not defined. So if you really take this as a function, sine mod x, sine greatest integer x upon greatest integer x, f of x is equal to, then what is the domain? If I ask you question, what is the domain of this function? You will say the domain will be, what will be the domain of this function? Domain of the function will be minus infinity to 0, open interval, union, you are okay with 1, so closed interval 1 to plus infinity. बघा जमतंय का? काय explanation आहे ते? This is what is going to be the domain of this function, because if you put any value from 0 to open interval 1, you will be getting the situation like this, which is illegal, which we do not have any idea. And this is not limit. I mean, this is just, if it was limit as sine something tending to 0 and something tending to 0, then the answer would have been 1. But it is not the limit. It is just the function that we are talking about. The domain of this function is this. And therefore, when you are asked to find out limit as x tends to 0, that means you can tend to 0 only from one side. That is from negative side. You do not have the values of the x to tend to 0 from right hand side. And therefore, left hand limit is 1, LHL is equal to 1. And right hand limit, there is no question of right hand limit, because domain does not allow you to take right hand limit. And therefore, the answer is sine 1. It is because you are supposed to evaluate from only one side and not other side. समझ Any questions? So limit is sine 1. Okay. I have a couple of more interesting limits. Let us finish them before 12:30. Next problem is question 14. Limit x tends to 0, greatest integer, mod sin x upon mod x. सांगा. Okay, correct answer for this is 0. Question 15. Limit x tends to 0. Fractional part of sine of signum of x upon signum of x. Fractional part of sine of signum of x upon signum of x. Last problem, limit x tends to 0, sine fractional part of x upon fractional part of x. Answer for 15th problem is sine 1. If you take right hand limit 0 plus, it is as good as you remove fractional part. Limit sine x upon x. We know that RH limit is equal to 1. Because as you go to 0 from right hand side, fractional part of x is x only. Therefore, sine x upon x, as you go near 0, it is the standard limit, which is 1. However, if you go from left hand side near 0, it will be sine minus 1 upon minus 1, which is going to be sine 1. So, right hand limit is going to be equal to sine 1, and both of them are not equal, therefore does not exist, is the answer. Okay, that is where we stop.